Today we're looking at square root and cube root functions, and we are going to look more in depth at these over the next few days. This first one that is graphed for you is y equals the square root of x. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and I want you to notice that this graph ends at 0, 0. Notice this graph does not continue to the left of the origin, because what if we tried to plug in the square root of -4? What would we get? We would get an imaginary number, and we can't graph imaginary numbers. So this graph ends at 0, 0 and does not continue on to the left. It's just this one little piece. And it kind of looks like half of a parabola that's been kind of turned onto its side. So it's like a sideways parabola, but only one side of it. In the calculator, if you have a graphing calculator and you want to play along, we are going to graph y equals the square root of x plus 2. So I'm going to do second and then the square button to get my square root of x plus 2. And notice that I put the plus 2 underneath the radical. Anyone have a guess what is going to happen with the graph when we add 2 with the x? Any guesses?
What was your question? Shift right.
It's going to shift right, left,
Right.
up, down, something. It's going to shift. That's a good guess. And if we look at the graph, it actually shifts to the left. And if I grab some of these points to graph, notice what happens beyond -2. See the error? If you look at y equals the square root of x, starting at -1, there would be error. That's why there are no points to the left of the origin. But on this one, we have the point -2, 0, -1, 1, and 2, 2. So -2, 0, -1, 1, and 2, 2. Okay, this graph has been shifted left 2 from the original graph. So what you might notice is, just like every other time that we have graphed functions, if you are adding or subtracting something inside the radical with the x, inside the parentheses, inside the bars with x, it does the opposite of what you would expect. So -2 in part B is going to move this graph right 2. And if you want me to quick type this in here so you can, there's the graph moved right 2. So how does the +2 affect the graph? It moves the graph left 2. How does the -2 affect it? It moves the graph right 2. What do you think would happen if underneath the radical it said x minus 4?
Right.
Right 4. So what does that plus or minus mean? Plus moves the graph to the left, minus moves the graph to the right. And you might start noticing, I feel like we've done this before, because we have. Every single type of function that we graph, whatever changes inside with the x affects horizontal movement and it's backwards. Next, we're going to look at the cube root function. Now, you can take the cube root of negative numbers. The cube root of -8 is -2. The cube root of +8 is +2. So you can do both. This, honestly, to me, looks like when you take a paper clip and bend it out, it looks like that bending spot. And the spot where it changes directions is called the inflection point. That's where it changes from one part of the curve, it kind of switches directions and makes that S. So in this one, we have y equals the cube root of x. Notice this time we are doing the cube root of x plus 2, and the plus 2 is not under the radical. So I'm going to do the cube root of x. I'm going to get out from under the radical and then add 2. What do you think this is going to do to the graph? We've already done left and right, so up. And notice that inflection point is now at 0, 2, because we moved the graph up 2. And if I want to grab some points here, I've got -1, 1, 0, 2, 1, 3. Those are really the important points. And this graph looks like this. So what do you think the -2 would do? Okay, because that -2 is not under the radical, it's going to move it down 2. So the +2 moves it up 2, -2 down 2. What if it said -29? What would that do? You have to look at, oh, first of all, this is supposed to be a cube root right here. There's kind of a typo there. But if it said -29 and that -29 was not under the radical, that would be up or down. So it would be down 29 units. So you may want to write on here, mine kind of got cut off, but plus means up and minus means down. Next, we're going to look at what happens if we have a number in front. And some of you who have remembered the graphing that we've done, you may already know this. We are going to do 5 times the square root of x. Do you notice anything interesting about that picture?
It's multiplied by 5, making it skinnier.
It's skinnier, taller, whatever you want to call it. If we grab some points, 0, 0, 1, 5, and 4, 10. So 0, 0, 1, 1, 2, 3, 4, 5. So here's this graph of y equals 5 times the square root of x. So you may want to point at that 5 and say that that 5 stretches the graph. It's called a vertical stretch. You're taking the graph and pulling it vertically, and that makes it taller, and some people call it narrower, skinnier, whatever. So what do you suppose in part B the 1/2 is going to do?
Stretch it. Make it wider.
It's going to smush it. So if in my calculator I put y equals 1/2 times the square root of x, it's a very, very smushed, wide looking graph. The points are 0, 0, 1, 0.5, and 4, 1. So it's a very, very small, smushed graph. So you may want to add this thing to your notes. Technically, that's addressed in the questions below, but it might be helpful to have it written there with your notes. Okay, now what do you think is going to happen if we put a negative in front of the graph?
It's going to flip.
It's going to flip it. So if we look here at -2 times the square root of x, this graph is going to have the points 0, 0, 1, -1, and oops, nope, because it's times -2. So 1, -2, and 4, -4. Or I could just look at the table instead of guessing on those points. There we go. So 0, 0, 1, -2, and 2, 3, 4. Okay, that negative flips the graph. Okay, and then I won't give these to you very often because I don't like talking about horizontal flips. Typically when we talk about flips, we're talking about vertical flips. We flip it over the x-axis from above down to below. But if there's a negative inside the radical, take a look at what it does. It flips that graph horizontally. So a negative underneath the radical would do a horizontal flip, which is kind of weird. It would make the graph look like this. Now, I'm not going to give those to you very often because honestly, they're just kind of weird. Down here at the bottom of the page, write y equals, leave yourself a space, a times the nth root of x minus h. That minus h is under the radical. And then not under the radical, plus k. If there is a negative here, I'm going to write that a negative flips the graph. The a value stretches or shrinks. So if there's a number larger than 1, it stretches. Smaller than 1, that looks like an L, shrinks. So if it's a 2, 3, 4, 17, whatever, it's going to stretch that and make the graph taller. If it's a 1/2, 1/3, 2/3, 0.2, 0.001, it's going to smash it, shrink it, make it shorter. The minus h under the radical, this is the side-to-side horizontal movement, and it is backwards. So plus means left, and minus means right. And finally, k is the vertical. It's the up or down movement, and it's completely normal. Plus moves the graph up, minus moves the graph down. And it does not matter if this, excuse me, is a square root or a cube root or a fifth root or a seventh root. These letters are the same in all of those forms, and they do the same thing in all of those forms. So your assignment for today is on the next page. And as long as you have this guideline for the equation, you should be fine. You can check these in the calculator if you want to, but you shouldn't really have to. So for horizontal, I want you to write down how many units does this thing move left or right. Make sure you put a number and a direction. If it doesn't move left or right at all, you can write the word none. For vertical, I want you to look at how much that thing moves up or down. Put a direction and a number. If there's a problem where there isn't anything added at the end, you can write none. For stretch, I want you to say stretch or shrink or none. For direction, I want you to basically write down, is there a flip or is there none? I took out all of the horizontal flips on this. It should just be vertical flips. So is there a flip or not? So your assignment for next time is to look at numbers 9 through 14 and think about this thing that we just went through and predict what each of those graphs are going to look like based on their equations.